So, good morning, everyone. Welcome to my one shot on P block for JEE mains, and also you can also use this for NEET, as this has all the information which is covered in your NCERT books. And I'll provide the timestamp in the comments from when you can skip my yapping and begin studying. But I want to give some background information about me first. I want you to know that I am not an old man 40 to 50 years old. I am actually a 17-year-old who is working to crack competitive exams, and I feel like I should do this, like teach others so I can retain memory better. And if I'm doing something for you and also for myself, I cannot hold back in providing quality content. So I can assure you that the information and content I'm providing is sufficient for your JEE mains and also NEET. But you have to promise me that after watching this one shot, you will have to go and do questions yourself and solve previous year questions of your respective competitive exam, be it JEE mains or NEET. So let's begin. And I'm sorry if this goes wrong. This is my first lecture I'm taking. And in this lecture, we will be covering the 13th group of the periodic table, which you can call the boron family. So let's begin with some general points about p block elements. What are some, what a G, general points of p block elements? Well, first of all, I want you to know that there is something called the inert pair effect. Now, what is the inert pair effect? The inert pair effect is basically, you know how elements have configurations like, say, NS2, NP6, N minus 1, D10, blah blah blah. So, what happens is that in heavier elements, for example, say lead, atomic number is in the 80s, and maybe say you can say thallium. These are not elements of 13th group, but I am still just taking examples. So what happens is that in heavier elements of p block elements, the 2s electrons right here, they tend to not be participating in chemical reactions. And as you see, these are two electrons, these are a pair of electrons, and hence we call them pair. And inert means they don't take part in chemical reactions, so we call them inert, and this is hence the name inert pair effect. Now an example of this is how the oxidation state of +1 gets more stable down the group in comparison to the +3 group. But you will understand this better when we dive deeper into individual groups, so let's not concern ourselves with this yet. Now, another point I want you guys to know is that the metallic character of the elements, which means their tendency to act as a metal, it increases as we go from top to bottom. What does this mean? This means that as we go from top to bottom, their metallic character increases, means their non-metallic character decreases. I mean, yeah, no shit. But whenever the metallic character increases, we can say that stuff like their oxides become more basic because metal oxides are basic. And maybe we can also say that the they become more electropositive. You have learnt in periodic table that elements get more electronegative as we move from bottom to top. So top to bottom, electronegativity decreases. That means metallic character increases because metals are less electronegative. And another very basic point I just told you, that non-metal oxides are acidic. For example, carbon is a non-metal and its oxide CO2, if you add it to water, it will make H2CO3, which is a rather weak acid compared to like maybe HI, HCl, H2SO4, but it's still an acid and it can dissociate. It can give H plus and HCO3 minus. So, as you see, the non-metal oxide is acidic, but the metal oxides, on the other hand, they tend to be basic. All right. Now, another general point I want you to know that for every element of P block or every group of P block, even for group 13, 14, 15, 16, and so on, the first element of the group, which is say boron, carbon, nitrogen, oxygen, fluorine, all of these, they are slightly different than the rest of the elements of their respective groups. Now, why is that? Because these two have very minute differences from the rest of their elements. What differences, you might ask? Well, the exact nature of those differences are that first of all, they have small size. Like they are incredibly small. If you see the size difference between the second period and the third period, the size difference is huge. And these are all elements of the second period. And these are all smaller than, say, aluminium, silicon, and so on. I'm not going to name every counterpart of the element. And the other difference is that they do not have d orbitals. They do not have d orbitals. What does that imply? That means that if they do not have d orbitals, they cannot expand their octet and hence they are limited to a certain covalence. For example, nitrogen is forced to a maximum covalency of 4, which means that in any of its compounds, nitrogen cannot form more than 4 covalent bonds. NCl4, maybe I am exaggerating. Maybe it exists, but I'm just telling that this can exist. I am not a chemist. But NCl5 will definitely not exist because nitrogen cannot make more than 4 covalent bonds. Understood? And one more interesting thing I would like to tell you that the smaller elements of each group, which I just highlighted right now, they tend to make p pi multiple bonds. Excuse my throat, I have a cold. Now, since I told you they do not have any d pi bonds at all, sorry, they do not have d orbitals at all. So, of course, they use their p orbitals to form bonds. And you know, p orbitals can form multiple bonds like, array, just it's gone now, but okay. The p orbitals can form multiple bonds. For example, say C triple bond N, or C triple bond C, or N triple bond N, or C double bond O. You see how they are able to form one extra bond, or maybe even two extra bonds, as compared to the normal, say, diatomic molecule with only one single bond. Now, why is that? It's because they have p orbitals, and the p orbitals like px, py, pz, they all just are perpendicular to the internuclear axis, and hence they can overlap with each other. Like this is the internuclear axis, p orbitals are like this, and they just like overlap with each other, and hence this double bond or maybe even triple bond forms like this. My diagrams are pretty disgusting, but maybe you can put up with that. You don't have to do this much detail in P block. All this you study in chemical bonding. And to be very honest, I do not have the OCAT to teach you chemical bonding yet. So let's just do P block. So higher elements of these groups can form d pi p pi or d pi bonds, but they will never be as strong as p pi bonds. Why is that, you may ask? Because p pi are basically they overlap better compared to the d orbital, and also they are smaller in size. Also, they have lesser energy, which means they can form better bonds. Now, all these general points we have noted. I will share you the PDF, but I don't think that's going to help you much because it looks like a bag of shit. But maybe it will help you. I'll link it in the description if you want. But only if you ask, okay? If any one of you asks for the PDF, I'm going to share it. Now, let's start with group 13, the first part of our one shot lecture series. First of all, what are the group 13 elements? These are boron, aluminium, gallium, indium, and thallium. Now, I don't think you guys are allowed to get tattoos from your parents, but if you were, I would tell you to tattoo all of these elements on your forearm. Actually, no, don't do that because they might ban you from the exam center. But you know what kind of importance I'm talking about, right? So, I will tell about the general properties of the elements. Boron is the only non-metal here. I mean, some people even call it a metalloid. Metalloid is elements which have both properties of metals and non-metals. This is a bit gray area, but I would say go with what the NCERT says, metalloid. And for the rest of the elements, say aluminium, gallium, indium, thallium, they are all metals. All right. Now, this was basically the metallic character of the elements. And now let's talk about where do I find boron? So, ores of boron. Do you know what is an ore? I mean, you should know. An ore is basically a mineral or basically a source from where you can get this metal. Okay, so first ore is borax. Borax formula you have to learn by heart. I am sorry, there is no trick you can use to learn. But luckily, it isn't a very difficult formula. You have to do Na2 B4 O7 dot 10 water of crystallization. Alright, this is the formula for borax. You have to remember it by heart. You can make notes side by side, or I will provide you the class notes later. But all I want you to do is please listen carefully and try to retain as much information as you can. Keep a rough copy with you, and as far as I am saying stuff, you need to write it down along with me, and this will boost your retention by up to 20 or 30%. Alright, now let's talk about kernite. Kernite is basically the same as borax, Na2B4O7. But instead of 10, it has 4 waters of crystallization. And just for future reference, I am going to write water of crystallization as AQ. So I don't have to write the bulky H and O and 2 again and again. It's annoying as hell. So borax and kernite, you remember. Now next, the last ore you have to learn is orthoboric acid. Orthoboric acid. Its formula is, it does not have water of crystallization. Its formula is H3BO3, or you can, some people also write it as BOH whole thrice. So you have to keep this hammered into your memory, because a question from this is almost liable in every examination. Like not from the ores, but using these compounds, especially borax and orthoboric acid. Kernite might not be that important, but who am I to judge? After all, NTA can ask, and whatever they can ask, you have to know. Otherwise, how else will you do questions? So, these were the ores. We are not going to learn about the properties of these ores or where they are found, because those are not relevant for our syllabus of JEE mains. For JEE advanced, you might have to know, but for JEE mains, this is enough. Now, let's talk about the abundance of boron, abundance or other properties in general. Boron is the element you have to study in the most detail, by the way. So, boron makes up 10 raised to power minus 4% of the crust. That is an incredibly small amount on paper, but once you realize how big the earth really is, it makes up quite a substantial amount of our crust. Okay, and if I'm not wrong, this is maybe equivalent to 1 ppm. Like, I don't know, but just cross check once. Now this is a very important point. I would say you should tattoo this on your heart. I mean, no, don't do that, that's too violent. But Boron has two isotopes. Which isotopes? Well, boron with atomic number 5 and mass 10, and boron with atomic number 5 and mass 11. Alright, these are your two isotopes, and this exists in 19% of the total boron present on Earth, and this is 81% of the total boron present on Earth. Now you know nuclei get more stable as we add more protons. Sorry, add more neutrons. So maybe you can use this fact as a way to remember that the nuclei with more number of nucleons are more stable and hence higher in percentage. Now I guess we are done with boron here. Yeah, that's it. Now let's talk about aluminium. What is aluminium? Aluminium is Al. Now I want you to know aluminium is most common metal on the entirety of our planet. Excuse my throat. And overall, in the entire periodic table, it is the third most common element after oxygen and silicon, if I'm not wrong. One second, let me have water. Now, while all of this I've said, where was I? Yeah, so these two facts I want you to remember. Then, what are the ores of aluminium? There are only two. First, second, the first ore I want you to know, it is bauxite. What is bauxite? Bauxite is basically aluminium oxide, which you already know, have studied in class 10th, Al2O3. But it has two waters of crystallization. And then there's cryolite, which is Na3Al See, aluminium is in plus 3 here. Plus 3 comes from sodium, and then it is counterbalanced by the 6 negative fluoride ions. So it is overall neutral. Okay, this is a way to remember the formula. Now, I want to mention one element that I haven't mentioned yet, nihonium. Why haven't I mentioned this yet? Because it is a relatively unstable element and we haven't studied it enough. And honestly, I would just skip over this section. But since the NCERT holds information about it, I want to tell you guys about it. We will mention it on this slide and then we will not talk about it on any other slide. So we have nihonium. Its atomic number is 113. Its atomic mass is 286. Its electronic configuration is that of radon, but followed by 14 F electrons, 6d10, 7s2, 7p1. You don't have to remember this. I am just telling it because it is in the NCERT. And the half life of most stable nihonium isotope is 20 seconds. I guess you can now tell why we are not able to study this compound to its full potential, because it's a very shy element. It does not like being seen by us. It just disintegrates. It would rather, its social anxiety is to that point that it would rather disintegrate than interact with any of us. And honestly, that makes me sad because I am a nice person. Somebody should promise Nihonium we are not going to do bad things to it, but I guess it'll take time. I guess that's it. That's all about Nihonium. Now, here comes the most important part. If your eyes or ears now get distracted from this lecture, you are not going to solve P block elements questions in your exam. I mean, yeah, I'm over exaggerating, but yeah, please listen and don't get distracted by any ads. I am not putting ads on my video or any other video you have to watch. Watch it later, but currently pay attention. Oh, and also I'm learning spoken English, so please excuse my bakwas. Okay? Now, first of all, let's talk about the atomic radius. The atomic radius increases top to bottom. Why does it increase? Because the number of shells increases. But there is one exception to this. Did you think you are going to study inorganic chemistry and no exceptions would be there? That's like trying to jump in an ocean and expecting there to be no salt. But okay, atomic radius increases top to bottom, and the exception is that the atomic radius of aluminium is greater than that of gallium. Well, just for reference, I'll just show you the order: boron, aluminium, gallium, indium, thallium. Like this is top to bottom of periodic table. Okay, now we expected the radius to increase continuously from boron to thallium, but this is only one exception, that aluminium is greater than gallium, but we expected aluminium to be smaller than gallium. Now what is the reason of this exception? It is because the 10 3d electrons of gallium have poor shielding, and hence they are not able to shield the outer electrons of gallium from the increased nuclear charge, and hence they are pulled back in by the nucleus, which causes its size to shrink just a bit smaller than aluminium. In fact, they are almost equal, but gallium happens to just be a little smaller than aluminium. Okay. Now, let's talk about ionization enthalpy. Now, ionization enthalpy is basically the energy needed to remove an electron from the outermost shell of an atom. You have studied this in chemical bonding and also periodic table. There is no fixed order which take place, so you have to remember this order: boron, thallium, gallium, aluminium, indium. How the hell do I remember this order? Well, Bombay to Goa, all are Indians. Some patriotism with P block. Such a nice combo. So remember this order for ionization enthalpy. Alright. The electronegativity the electronegativity decreases from boron to aluminium, but then there is a small increase from top to bottom. Like boron greater than aluminium, but then all the subsequent elements are greater than aluminium. So that's how you have to deal with that. It's a very weird order, but yeah, just put up with it. And also don't forget to read the NCERT after this lecture, because that is of course necessary. Like, I am covering everything in NCERT, but having a written source in front of you is always better. Alright. And if you are holding the NCERT along with me as I speak, you will realize that I am speaking points which are taken directly from the pages. Now let's talk about the physical properties of group 13 elements. 1. Boron is black, hard, solid, uh, boron is black, hard, solid, and it has high melting point because of a strong lattice. What does this mean? What is a lattice? Lattice is basically how the atoms exist together. Like maybe boron exists like this, where in a cube, where 8 boron atoms are combined with each other, and then this cube just extends. and that is the entire lattice. So whenever this lattice is strong, you have to provide higher temperature to break these metallic bonds. Not metallic, but you have to give higher temperature to break these bonds, and hence the strong lattice is the reason it has a high melting point. But the rest of the elements are soft metals. You know the aluminium foil in which you take food to school, that is soft metal because aluminium is a soft metal. And they also have low electrical conductance, like they are not really good conductors. Now there's another point here. Gallium has exceptionally, that took a while to write, exceptionally low melting point. Why is that? We are not going to dive into it because the NCERT does not mention. But I'll just give a small reason. It has a low melting point because it does not have a very strong lattice and it exists as diatomic molecules. But very high boiling point. Now this has an interesting consequence. Now you see one thing, it has a high boiling point, which means a lot of heat is needed to make it change from a liquid into a gas. Right. But it has very low melting point, which means a very low temperature is needed to make it from a solid to a liquid, which means gallium has a long liquid life. You know what I'm saying? Like, for the most of the temperature that we chemists usually use in our reactions, gallium will stay a liquid for most of those reactions because it has a very low melting point and a very high boiling point. So it tends to stay as a liquid in the temperatures that we deal. Okay? And hence it is used in thermometers called pyrometers, which are used to measure high temperatures. Mercury usually cannot stand that well. Now, for melting points of the elements, I want you to remember this order: boron greater than aluminium, greater than thallium, greater than indium, greater than gallium. How do I remember this order? Just say batting. Like you know, in cricket they do batting: B for B, A for L, T for thallium, I for iron, and G for Ga. Easy. And boiling point, last physical property. Boiling point is a constant decrease from top to bottom, which means boron has the highest and thallium has the lowest. Now last part we have to study in chemical properties is chemical properties. Now write this point in your hearts. Boron never makes ionic bonds, and never means never. You know, boron is the only non-metal here, and non-metals tend to make covalent bonds. So yeah, just remember it like this. Boron never makes ionic bonds because it has a +3 oxidation state. So of course, it has more covalency according to Fajan's rules. You know, the better oxidation state, like higher positive oxidation state of a cation, they are better in pulling the electron cloud of the anion which holds them, and hence this makes them more covalent. Okay. Now, the another thing I want to know, compounds like say BCl3, AlCl3, these are all Lewis acids. Why? Because you see the structure. This is the boron, this is chlorine, chlorine, chlorine. Two electrons here, two here, two here. But for an octet, you need 8 electrons. But here it is missing 2 electrons. So sometimes what happens, it can take a electron pair from any other source and this can form basically a coordinate bond. So this is how they act as Lewis acids, by accepting lone pairs from donors. Okay, and the tendency to act as a Lewis acid decreases top to bottom. What does this mean? BCl3 will be the best Lewis acid compared to AlCl3, GaCl3, dot 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 TlCl3. We are not going to go there. So excuse me, my throat is acting up. So and except for boron halides, all others form a dimer. What is this dimer? Dimer, when say two molecules, same molecules, they combine to be more stable in the solution. So this is what happens with say like AlCl3. AlCl3 does not exist like AlCl3 molecules. It rather exists like there's Al here, and there are multiple Cl surrounding them, like this. This is how they exist. This is the dimer. Like as you can tell, this is one AlCl3, this is other. They form dimers to be more stable. Okay, and I think that's beautiful. Now, these are some useless facts. You can skip this portion. But I just want you to know this angle is 118 degrees. This angle is 101 degrees. This bond length is 206 picometer. But this bond length is 221 picometers. You don't have to remember the absolute values, but just remember that this bond is longer than this bond and this angle is greater than this angle. They might ask it, we never know. Now, let's learn about their reaction with water. You don't have to remember the properties of their compounds for JEE mains, but you have to remember the reactions with water, air, halogens, and acid and bases. They are not too difficult. So, trivalent group 13 compound, like say halide, it reacts with water to form MOH4 minus, where M is the metal. Basically, what happens? 4 hydroxide ions substitute this, and substitute 3. Basically, I'll just draw it. 4 hydroxide ions substitute this and form MOH whole thrice, and it accepts an extra OH minus to get MOH4. Okay, MOH4, and there is a negative charge now because it has an extra pair of electrons. But there's an exception to this. If you have AlCl3 and you add it to acidic water, like the pH grade less than 7, so it will basically form a complex with 6 waters with plus 3 charge, since water is a neutral. Next, let's talk about air. For air, remember that boron does no reaction with air in its crystal lattice, and aluminium forms a layer with air which stops further reaction. Overall, no reaction. Okay, now for the rest of the elements, you can say that 2m plus 3O2, air has oxygen, so it forms M2O3, and 2m plus N2, air also has nitrogen, forms Mn. This is for the rest of the elements, and just remember this as a fact, they are not very difficult reactions. Okay, and one fact I wanted to add, just remember this word, M is amorphous. I will not explain what amorphous means, just remember this. Okay, it has something to do with solid state. I am not going to dive into that. And then there's halogen. They react with halogens to form 2m plus 3x2 gives Fe2MX3, the same Lewis acid we talked about earlier. Now there's one exception. This can't form TLI3. Just remember this, okay? It cannot form thallium iodide. And lastly, with acids or bases, boron shows no reaction, and but aluminium has an interesting property that aluminium is amphoteric. So what it does is basically with both acid and base, it releases H2 gas. Okay, and aluminium does not react with HNO3 because it forms a protective layer. Well, that is it. Entire group 13 and general properties I have covered. I'm sorry if this lecture is long. You can watch it in 3x or 2x. 3x? No, watch it in 2x. 3x will be too much. But I can confirm that I have covered almost every point in the NCERT. If I have missed something, please don't hesitate to write it down in the comments and I am going to pin that comment so others can read. Okay? Thank you everyone and have a nice day. Tell me if you want further groups.